The other reason why a function might have a limit is called a discontinuity. This time we'll use the function y equals minus x squared over x. Now at first glance this wouldn't seem to be a function that's going to give us much trouble, especially since once we apply a little bit of algebra it simplifies out to y equals minus x. This graphs out to a ski slope line with a slope of 1 and a y-intercept at the origin. Okay, now I bet you're wondering how Steve got down there. Let's take another look at our function before we simplified it. What happens to y when x equals 0? At that point, the function evaluates to 0 over 0, which is undefined, which is a fancy way of saying, I don't know. It looks like it goes to 0, but we don't know that it does. For all we know, it could go to infinity, or it could even go to Buffalo for a fun weekend, although that's highly unlikely. The point is, it's data we don't have, so it creates a hole or a discontinuity in our function. It's far too small to see, but it's there nonetheless, and while our simplifications might have seemed to take it away, algebraic simplifications can't actually create data points where none exist. All the simplification really did was to paper over the hole. So we can't say that we know for certain what y is at x equals 0, but both the simplification and the graph give us a pretty strong indication that y goes to 0 at that point. So, just like with our first example, we use the concept of the limit to state that our best guess for the value of y at x equals 0 is, in fact, 0.